Hi everybody. I got the power. I got the power. I love the power. I love the power. La 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 la.
Hello again, Nashville Software School students. This is Steve Brownlee, your lead instructor. This video, we're going to talk about promises and the power that they can bring to making your code a little bit easier to maintain, a little bit easier to understand. So, the little project I've thrown together here is somewhat of a very basic implementation of Google Maps, just to kind of set the stage for you here. I've taken a screenshot of my hometown on Google Maps, which is Pittsburgh, and I've broken it up into 6 different images, and I want to load those images via an XHR. So we have an asynchronous operation for every single one of these images. Then I want to take those images and display them in a grid, just like Google Maps would do, because that's really what they don't load one giant image at a time. It's actually a bunch of grid images, and they get loaded asynchronously and displayed in the right position on the page. This is a very basic implementation of that. So here we start with the HTML just for the structure of the document. You can see here on line 7 I'm pulling in Bootstrap just so I can use their grid system. For the grid itself, I've got 4 rows. The top row, I'm just going to load, basically I took a snapshot of the browser toolbar at the very top. And then for the next 3 rows are the actual grid images that I took snapshots of that I'm going to load asynchronously. Then down the bottom, I have the actual JavaScript files that are going to contain those XHRs so that I can start loading them. The bottom, I have a grid set up. Basically, that's going to be the JavaScript file that kicks off the entire process, and then each one of these images is going to get loaded at a specific point in time. Let's take a look at grid setup. Okay, there you can see the only thing it does is it executes a function called getGrid001. That's in grid1.js. There's where I define that function. Okay, so basically you can see in here a XHR where I'm loading in down here. In the images directory, I've got a grid001. They're all named the same. When that loads, come up here to the load function. I'm just console logging in a message, grabbing the entire response, which is the image, and loading it to a little variable called blob, identifying the exact grid. Then I'm identifying the exact DOM element that I want to load that image into. Just so happens to be the element with a class of grid01. And then these next 2 lines are just using the new HTML5 file API to actually assign that image to the source attribute of an image tag I have inside of each one. Let's go back and take a look at that real quick. So you'll see it inside of each one of these. You'll see inside of each one of these rows and each one of these grid blocks. So, grid 1, 2, 3, 4, 5, 6. So these are the image tags where I'm actually taking the image that I load via XHR and setting the source attribute. Once that image is loaded onto the DOM, I'm saying, what next? So load the image, load the next image. So execute getGrid02, and it just goes to these one at a time. Every single one of these files is almost identical. It's simply loading a different image. Here's grid02, and loading it into a different DOM element of grid-02, and then specifying which one to go to next. And it just keeps going and going and going and going until lastly we get to the get toolbar. We load in that image. Same thing happens here. I'm just going to log a message, get onto the DOM, and then the process is done. Let's take a real quick look to see how that operates. I'm going to load up my browser. You can see it already here, but let's just watch it in action. You can see the console log messages showing up on the side, and then the image is getting dynamically loaded. And I didn't point this out before, but if we look at each one of these, I just paused it. I put it in a set timeout, 2.75 seconds, just to show the process, because if I didn't put that in there, it just happened too fast, and you don't actually see the process happen. So I very clearly defined the structure of my page. This one kicks off the process of grid setup, and then it just goes one at a time and fills out those grid elements going horizontally, one row at a time. Pretty similar to JavaScript that you've seen so far. This is using the file API, which you probably haven't seen, but it's a way to load images, and you're used to loading JSON documents, but you can load images as well. So the way I showed you the file, the way it's set up now, this application has sprinkled the responsibility of the order of operations amongst all of these files that you see in this visualization. Grid setup only has one responsibility at this point. It's to kick off the process and say what function should be executed first. But that as soon as we jump to grid 1, that now has two responsibilities. It's to get that image from the file system onto the browser, but it's also got the responsibility of saying what's the next step in the process. So that actually becomes a problem over time as our system becomes more complex. Because if in the future we want to change this sequence of events, instead of loading from left to right one row at a time, let's say we want to load one column at a time. So, a new developer comes onto the team and they're going to come to the system. So the first time they come in here, it's pretty straightforward. They open up all these files. It's pretty straightforward. Grid 1 goes to 2, and 2 goes to 3, and so on and so forth. But their job is to change it. So if we do it by columns, 1 will go to 3, 3 will go to 5, 5 will go to 2, 2 will go to 4, and 4 will go to 6. So, then another developer comes along and they open up all these files to see how the grid is loaded. And they're like, what the heck is going on here? Why would 1 go to 3? These files are named grid 1 through 6, but then they're not loaded in that order. And it just becomes hard to maintain. It's hard to get that mental context of how the system operates. And let's say their job is they now need to load them diagonally in an X pattern. It's a ridiculous example, but this is how systems change over time. When you are a software developer, you could be working on a system that has evolved over many years. And you'll look at a piece of functionality that has now been spread perhaps across a dozen files, and you will have to read all of that and gain a mental context of how all these files work together to accomplish a goal. So the better job we can do of showing how the order of execution for this simple application works, it makes the job of every developer easier. So, they load it in the X pattern, and, their job is done. They're happy with what they've done. But then the next developer comes along, and now it makes even less sense. 1 goes to 4, 4 goes to 2, 2 goes to 6, and there's absolutely no pattern to this whatsoever. And they come along and said, whoever wrote this application was stupid. This is ridiculous. Why would you do this? Because they don't have the history. And all they see is the code as it is at that point in time. So promises is one way to actually make the code easier to understand and easier to control the flow of the application. In addition to the technical purpose of it, which is to wrap around an asynchronous operation to then execute other code when the function is complete or when the function has failed. And that will be a departure from the way the code is written right now, which is very rigid, very locked in place, and very hard to maintain and change. So we want to take the code from how it looks now into looking something like this. We're actually going to take the order of execution. We're going to put it all in one file into grid setup so that every developer who comes in here can open up one file and one file only and just see in about 10 lines of code how the system is going to operate instead of having to open up 8 files to understand how the system operates. So let's jump back to the code. I'll put in some promises and show how that syntax can help make the system easier to comprehend. Here's where we left off, and let's just do a very simplistic implementation of what we just saw in that animation. Let's take all of the steps that are needed and just put them right here in grid setup. So I'm going to come over here to grid 1, get grid 2, take it out of there, put it over here in grid setup. So I'm just going to go one by one, and I'm just going to do this the easy way right now. So 3, 4, 5, 6 toolbar. All right, so I'm going to go ahead and clean up all the other files, and then I'll be right back. Okay, all the other files had the order of execution instruction taken out of it, and it is now here in grid setup. So I'm going to go back to the browser and show you what it looks like when I just fire these off sequentially. Okay, you'll see that they basically loaded in random order, because you never know when you have asynchronous operations, you never really know how long it's going to take, because there are a variety of issues that can cause something that normally takes 30 milliseconds. It could all of a sudden take 1 full second or 2 full seconds because of network issues, or something with the hard drive in the system is just overloaded. So you're never sure how long an asynchronous operation is going to take because of these issues. And you'll even see here in the console, 2, 3, 4, 6, toolbar 5, 1. If I reload this again, it's going to be a completely different order. 4, 6, 1, 2, 3, 5, toolbar. Okay? Simulated asynchronous operations. So promises being wrapped around these asynchronous operations and resolving and rejecting when it is complete allows us to add that level of synchronicity, making sure that these asynchronous operations do get loaded in a predictable order. So let's go back to the code and take a look at how we can use promises to get there. So right now, all of these grid image operations simply do their job. These functions don't actually return anything. They simply perform the logic that's inside of them, and then that's it. There's no return value on these. But with promises, what we can do is make each one of these functions now return a promise. Each one of them will be a promise that will resolve or reject on completion or on error. So let's go look at grid 1, and I'll show you how to wrap this operation up in there. Basically, this entire series of instructions is the asynchronous operation. So basically all the code inside this function, I'm going to wrap inside a promise. And this function will return a promise. Okay, so the function can actually use the then method, which you'll see later, to make this work synchronously. So I'm going to return a new promise. Okay, now the promise itself has one argument, and that argument is a function. So I'm just going to kind of put a lambda expression in here for now. This function takes 2 lambda expressions itself. Basically, we're going to be passing in 2 function references into this. Okay, the logic that we want to happen if the promise resolves, meaning it all worked correctly, and the function containing the logic that we want to run if the promise is rejected, meaning an error happened. All right, the value of these 2 arguments will be functions. So we're still using callback functions like you've been using so far, but now these callback functions that are getting passed into the promise itself follow a consistent pattern. It's a consistent method signature. So when we go back to grid setup and we start chaining these promises together, the code is much more clean, the code is much more easy to understand, because you're following the exact same pattern every time. So now I'm going to take all of these operations, I'm going to move it up into the promise and indent it. All right, so what is resolve? Resolve is when we know that the operation has been completed 100% to completion. So let's look through this code and find out where we know that. Up here is where load, that's kind of when we know that at least the file is retrieved from the file system. All right, we get the response, we put it on the DOM. So basically, after we set the source right here, which is where we used to call the next step in the process, this is where we are fairly sure that we know the process succeeded and the image is now on the page. So what we're going to do is we're going to resolve the promise here. And likewise, where we think the promise should be rejected is down here in the error method, or the error event. Okay, something went wrong, so we're going to reject the promise so that the chain does not continue because we got an error in our code. So now this promise is resolved. I'm going to go back to change grid setup. So now getGrid1 function returns a promise, and every promise has this special method on it called then. Whoops, I misspelled it. All right. Then is where we can set up these resolve and reject functions that we want to send in. Okay. That's where the two sync up. This function returns the promise, but where we define the function references that are going to be executed in resolve or reject happen right here. Okay. This then method actually takes those arguments. So the logic that we're going to put inside this function is going to be what we want to execute when resolve is invoked. And the second method is the reject logic. So for now, we're just going to put a console log in here. Grid image 1 successfully loaded. And similarly for the reject message, we'll just put not successfully loaded. Let's see what happens here. So I've just changed grid setup 1, or get grid 1. Okay. Loading grid image 1 successfully loaded. So now we know the promise resolved, and we got into this resolve handler here. Okay, but that's just the first step. We've now made the loading of grid image 1 a promise that can resolve or reject. But in order to make this entire thing work as kind of an orchestra together and have the series of operations be in a predictable order, we have to go and change all of these functions to be promises. So I'm going to go ahead and do that, and I'll be right back. Okay, all the other functions are now promises. Went ahead and made that change. Just to verify 5, 6. There's 6. And toolbar. Okay, now all of these functions return promises. So let's start chaining them together the right way. So here in grid setup, we get this promise. Then when it is complete, right now all we're doing is console logging a message. But when that is complete, that's not what we want to happen. We want the next step in the process. Okay, we want get grid 2 to be invoked when get grid 1 resolves, meaning it was successful. So I'm going to put get grid 2 in there, and let's look at how this changes things, if at all. Okay, still looks kind of the same. 4 toolbar 3 1 6 5 2. Let's reload it again. Still looks kind of random, but you'll start to notice a pattern that 1 and 2 happen in the right order just in and of themselves, even though the rest of the images around them are still getting loaded randomly. Let's do it one more time just to prove that theory. Yep. 1 and 2. 1 and 2. So they are getting loaded in the right order. Okay, now that we are showing that the promises are working for images 1 and 2, let's chain all the rest of them up. So the then method itself returns a promise, but we don't want it to just return some random promise. We want it to return the promise of basically what we're doing in the next step. So I'm going to return get grid 002. So this then method is going to be resolved with, or have the return value of the promise that get grid 02 returns. So that means we can start chaining these together. This is the end of this then method. It will be this promise, which means we can put another then, just like this. I'm going to do some copy pasta here. Okay. Next up the process is 3. And so on and so forth. So I'm going to get this code to look like I want it to, and I'll be right back. Okay, so I've now set it up to have the full promise chain starting with 1, 2, 3, 4, 5, 6, and then toolbar. So I'm going to go back and I'm going to reload the browser, and we're hopefully see that all of these get loaded in the exact order that we wanted. Alright, so now we're back to the original functionality. They all got loaded in the right order, still with that simulated response time for each one of them. Let's reload just to verify that that happens again. 1, 2, 3, 4, 5, 6, and toolbar. There we go. So now we're using promises to achieve exactly what we had originally, where each one of those had the responsibility of saying which process came next. But now that order of execution is specified in one file, very easy to see instead of being sprinkled amongst all those other files. Alright, so like I said, this then method itself takes the resolve and the reject function references. Okay, that's what gets passed into each one of these promises. So since these are function references, basically what I want to invoke when the process is successful, and here I'm just writing this quick lambda function, instead of saying function return another function, this is even cleaner. Okay, let's see if that works. Alright, so that's the cleaner lambda syntax. If your function is only going to return one thing, you can leave out the curly braces and you can leave out the return statement. So I'm going to go clean up the other ones and I'll be right back. Alright, so I've cleaned up the code. Each one of these resolve functions is that clean lambda syntax where it's returning basically the next function that we want to be executed on resolve of the current one. Here you can see it's still working. There we go. Still working. Same order of execution, a little bit cleaner code. But why have a function return just another function? Why are we wrapping these resolve functions in another function? Why not just return the function itself? Let's make this even cleaner. I'm going to start off with just get grid 2 and get grid 3. And just return the function reference itself. Let's see if this works. Look at that, still worked. So I'm going to go ahead and clean up the other code, and I'll be right back. Alright, code cleaned up once again. Now the resolve function that is going to be passed into each one of these promises is just the function reference for the next step in the process. So this getGrid002 function reference is going to be the value of this resolve parameter right here. So down here is where we actually invoke it. So it's basically the same as if we said getGrid002 right there, which is exactly what we had before we refactored this to use promises. Okay, and that just keeps going down the chain. Each one of those resolves is going to be the next step in the process. We can do the same thing with the console.log. Let me change this up a little bit. Now, since this is the reject function right here, instead of console log, I want to console.error, each one of these. And I actually want to specify what the error is down here in grid 001. So during reject, I'm going to pass up to that function a parameter. Grid 1 failed to load. All right, that comes in here. Error message. Okay, and just like we did with the other ones, I can get rid of these curly braces. And just return that console error. Now, since these are all successful, that actually won't fire. And I actually can't make it force to fire because even if we change the URL, here, I'll show you. Let's change this to a file that does not exist. Let's put an X after this. This does not cause the error event listener to, or the event to be fired on an XHR. Okay. the fact that a 404 gets returned from this is not an error. It is still successfully doing its job, but it will simply say the file wasn't there. Error usually gets happened if there was a true error happening over the network, like it couldn't complete the request, or if for some reason the disk drive that you're trying to read from couldn't get access to a drive, that would return an error. So I'll show you. We don't actually see that console.error at all. Here's the browser telling us that there was a 404, but that's it. I'm going to go back to grid setup, and I'm going to, again, clean all of these up, and I'll bring you right back. Alright, got these all cleaned up. Let's run it, see if it still works. Alright, cool, still worked. But guess what? I can clean this up even more. Check this out. This will work just the same. Console.error. Okay, let's walk through this through. Console.error becomes the value of this reject. Okay, so this is holding a function reference to console.error. So down here where I invoke reject, it basically is console.error. That's what I'm doing here. So instead of putting the message over here, passing it up as an argument and then using it as an argument to console.error here and wrapping a function inside another function, I've now cleaned up my code even more. Alright, so let me get this all cleaned up, white space and everything, and I'll be right back. Okay, here we go. The cleanest possible code to get all of these grid tiles to load in the order that we want them with the least amount of code. No more wrapping functions inside of other functions. We're simply passing function references in to resolve and reject. Very simple, straightforward solution because this is a straightforward order of operations. So again, I'm going to load the browser, make sure this all works correctly. There we go. So the final thing I'm going to show you is, because of how clean this code is right now, it allows us to change the order of operations in one place just by moving some lines of code in one file. So instead of ordering them by rows, I'm going to order them by column. So after grid 1 is going to be grid 3, then grid 5, then grid 2, then grid 4, then grid 6, and then finally the toolbar. Let's see if that works. There we go. See how easy that was to change the order of operations. And now in the future, if the decision ever gets changed and how this sequence should happen, the next developer simply has to come to this file, change the order of the promises, and you're ready to go. Only one file gets open, one file gets modified, and now your code is more maintainable, easier to understand for anybody who wants to come in and read it. So I know this was a lot to absorb, and it took several steps to get here, so I hope you take the time to watch this video a few times and really try to wrap your brains around how I got from that original version where the order of operations was sprinkled amongst all these files into this new way of doing it. So thanks for watching. I hope this takes your understanding and comprehension of promises to the next level after you watch it a couple times, and we will see you in class.